Yes, let this be the last question of chapter number 2, the structure of atom. I want and this video is very special because it will be my 100th video that I'll be uploading. Um, I wish to continue this, so I'll be moving on to the next chapter, which is related to periodic table, chapter number 3. So let this be the final question that I'll be doing from I have been doing from the textbook. If there is any other question that you want me to solve, please comment me. I will try to solve it and upload it. Yes, let's consider this question. Question number 2.46 of NCERT textbook, chapter number 2, class 11. Nitrogen laser produces a radiation at a wavelength of 337.1 nanometer. If the number of photons emitted is 5.6 into 10 to the power 24, calculate the power of this laser. So what is a laser? It's an acronym of light amplification by stimulation of emission radiation, something like that. So it's like this is a laser, and light is emitted from it, and electromagnetic radiation is emitted from it, and it will have its wavelength is given. When you are given the wavelength, then you can calculate the frequency, right? Because for any electromagnetic radiation, the product of the frequency and the wavelength is constant. It will be its velocity, that is 3 into 10 to the power 8 meter per second, denoted by c here. So once frequency wavelength is given, that means you know the frequency. If frequency is given, you know the wavelength, right? You can calculate the wavelength. But they're saying power, like the power of something. If you want to calculate the power of something, means it's the work done in 1 second, in unit time. The work done in unit time. So there should be work done. There should be time, but there's no time given over here. Let's assume the question is saying if the number of photons emitted is 5.6 into 10 to the power 24. This many photons are emitted in how many seconds? That we don't know. So I'm just assuming this is emitted in 1 second, so that time we keep as 1 second, right? And then what is the work done? Means how much energy is produced, or how much energy is able to radiate. That is the work done. And how much you are, if for any electromagnetic radiation, when you are knowing the frequency, that means you can calculate we know that according to Max Planck, the energy is radiated is quantized. It will be radiated in terms of packets, and in each packet, the packet means photons, and energy of one photon is h into Planck's constant into frequency. That is the energy of one photon. And how many photons are emitted? This many photons are emitted. So this number will be n. Right? Energy of one photon multiplied by how many photons are there. That will be total energy. And since frequency is not given, we will write it in terms of wavelength. It will be c by wavelength. So Planck's constant is out. Now the rest is you just have to replace the values. H is the Planck's constant, is 6.626 into 10 to the power minus 34 joules second. C is the velocity of the electromagnetic radiation, is 3 into 10 to the power 8 meter per second. N is what? It's the total number of photons that are emitted in 1 second. I'm just assuming it's emitted in 1 second. So it's 5.6 into 10 to the power 24 divided by the lambda will come as a denominator. It will be 337.1 nano means 10 to the power minus 9 meter. So this will be in standard form. Since it is a power, it will be watt, or it will be joules per second. Joules per second. Others are just simplification. Multiply 6 5 are 30, 30 into 3. It should be 90, right? But what I have done is I have a 7. I've taken this as 7, taken this as 6, 7 is 42, 42 into 3 is 126. It's a rough calculation. I'm just approximate calculation I'm doing. But if you do it with the calculator, it will be, if you do the exact calculation, it will be around 0.3, and the power will be 10 to the power 7. So it is 3.3 into 10 to the power 6 joules per second. Or if you want to express in kilowatt, then it will be 3300 kilowatt, right? Or kilojoules per second. This is a simple question. Let's end it. Let's move on to the next chapter. Chapter number 3, periodic table. I'm excited. Let's do it. And if you want any question to be solved from this chapter or from the previous chapter, chapter number 1, please comment it.